Good morning, fifth graders. It is May 6th. It is a Wednesday. Let's talk about air pressure in science today. Your objective is to make some discoveries around the topic of air pressure. So let's take a look first of air pressure and weather. We're going to have high pressure and we have low pressure. So let's take a look at air pressure and weather. What is pressure? Pressure is the weight of air pressing on a unit area. And what do we already know is causing the air to press downward? The correct answer is gravity. And then we talked about in class, when we look at the atmosphere, it is not one single layer. It is in different layers. And remember the video that I showed you guys about when the airplane actually broke one of the sound barriers. So remember, it is in layers. Here's your sea level, and then it goes up, it goes up. It's on a certain part, though, that we can go. Then we go up, 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 and up. So remember that we are in layers. Air is in layers, just like the ocean is in layers. You notice, look at our image. As it goes higher, the balloon bursts. Just remember, it's only so far up in the atmosphere that we're able to go. So we have air pressure. Down here, there is lots of weight on me. I feel high pressure. But as the boys go up here, I have little weight on me, so I feel low pressure. So common sense, if I'm at the bottom, I'm going to have a lot of pressure because everything above me is pressing down. If I'm at the top, I'm going to have low pressure because there's nothing pressing on me but just air. Nothing's added to that air. Think about the ocean. The further down you go, the more pressure the water has on your body because you have more pressure from water pushing you downward. So it's the same concept. So, what causes air pressure? I'm glad you asked. The atmosphere also affects weather because its weight increases air pressure. Differences in air pressure causes air movement in the atmosphere. We feel this movement as wind. So, what would a definition of wind be? The definition of wind would be moving air. That's all that wind is. It is simply moving air. So when you listen to the TV and you have the meteorologist talking, and he's talking about a high pressure here and a low pressure there, this is what he's talking about. In a high pressure, the air sinks warm and it dries out. You have few clouds and it's kind of sunny. But when you have a low pressure, that means the air is rising. As it's rising, it's cooling and condensing. And we talked about condensing before. Condensing means to come together. That's when you're going to start to get clouds and rain. And remember, rain is part of the water cycle. It's part of precipitation. What is rain? It's when the cloud gets full, it releases the water. And why do you know it rains and not sleet, snow, or hail? It depends on the temperature of the what? Air. I hope you guys are realizing everything that I've taught you, they all interact together. You're not learning things in isolation. We always build upon things. This is why it's important that you learn the material when it's taught, because everything builds on top of each other. Nothing is in isolation. When you drink soda through a straw, air presses down on the soda and pushes it up through the straw to your mouth, where you create a partial vacuum. Air pressure is caused by air pressing down on the lowest layer of the air from above. Remember, I told you that the air is in layers. I have underlined this sentence. Air pressure is not the same everywhere. So that's why I have this little boy, this man, whatever, just running around on the earth. Now we know this is not realistic, but this will give you an example of what I'm talking about. The air pressure is not the same everywhere. Why not? The sun creates areas of high air pressure and areas of low air pressures. These areas on the map are called the high pressure and the low pressure. Now, what did I say wind is? Wind is simply moving air. It is caused by air flowing from the high pressure to the low pressure. Its direction is influenced by the Earth's rotation. And what direction does the Earth rotate? Pat yourself on the back if you said counterclockwise. So that's how we get a high pressure or low pressure. So once again, I think I told you the second, third day of school, the sun does what? Say it with me. Controls everything. We know air has mass. I knew I shouldn't have eaten all that air because remember, air is going to have mass. Whatever is in mass stays in mass. It does not change. So, what is air? People generally believe that air is composed mostly of oxygen. In fact, the term air and oxygen is often interchangeably. That is a misconception, meaning that is not true. The content of oxygen in the air is relatively small when compared to the gas nitrogen. So, in our little pie chart, what gets most of the pie? Nitrogen, 78%. Then the next part would be our oxygen, which is at about 21% if you round. And then we have a little small piece that gets all of the other parts of the air that makes up the air. So we think a lot about air as being oxygen, but really, we really need to refocus our thinking. Actually, air is more nitrogen than it is oxygen because we say a lot about H2O and trees gives us oxygen and we breathe it in oxygen. So we kind of need to change that vocabulary word and make it more of nitrogen because air is really 78% nitrogen. So air pressure is the force that air molecules push down on a surface. And you have the word pressure. Air is all around us, whether we like it or not. We cannot get away from air. Now, actually, will we even want to get away from air? No, we really kind of do need our nitrogen. So, why don't I feel all of that pressure and why doesn't all that pressure squash me? So remember, you have air inside of your body. That air balances out the pressure outside of your body, and therefore the result is that you don't feel any pressure. We have to have a balance, the balance in our bodies and out of our bodies. This is sometimes why we fall. Is what we say we lose our balance. Sometimes you can be walking or running, and out of clear blue sky, you just trip over and fall. You have lost your air balance. Now, what would happen to our bodies if the pressure inside our bodies was not balanced with the pressure outside of our bodies? So I'm going to give you a little minute to think about that. Remember the can? Think about what happened with the collapsing can. So if the pressure in our bodies did not balance with the pressure out of our bodies would be just like that can. So there's an interrelationship that affects air pressure. Humidity, the amount of water vapor in the atmosphere or in a gas, that is humidity. The altitude, the height of an object or point in relation to sea level or the ground level. In other words, the height. Then we have our temperature, the degree or intensity of heat present in a substance. So, in other words, how hot or how cold something is. That is your temperature. So, now this is important for you to remember. Air pressure decreases whenever the temperature, humidity, or altitude increases. They work against each other, they're the opposite. Say it again. Air pressure would decrease or go down when the humidity, the temperature, and the altitude increases or go up. So here are three examples. Warmer air brings what kind of air pressure? Now we know we have warm air because we see him sweating. He's in his shades, his hat, he has his umbrella. Atlas does a little heat training. He's in his swim trunks. Got a little sweat coming down. He's really tired. So warmer air will bring a lower air pressure. The warm air brings a lower air pressure. So the altitude is how high you go. So the altitude would affect the air pressure. So as the altitude increases, the air pressure will do what? It's going to decrease. It's going to go down. So now the people at the bottom of the pyramid, they can feel all the pressure. They feel this set weight, that weight, and they feel this weight. So the people at the bottom really need to be the strongest because they're going to feel all the bottom. The pressure on the top is not going to feel any pressure at all because they're at the top. So therefore, the people at the bottom of the pyramid feel all the weight and the pressure of the people at the top of the pyramid. So this would be your high pressure, because there's a lot of pressure. This would be your low pressure, because there's no pressure on the person at the top. So humidity also affects air pressure. In addition to gases, the air also contains moisture. We know it has moisture because we've already studied the water cycle. So we know there's moisture in the air. As the humidity or the moisture in the air increases, the air pressure is going to decrease. They do the opposite. So thank you, humidity. I always wanted to be Lion King. This is when I had hair. I remember I don't have any hair now. Matter of fact, you guys haven't seen it, but I actually shaved all of my hair out. But so I don't have humidity problem. But those of you who have long hair, you know all about humidity, especially in the summertime. When you go outside and your hair begins to frizz and you look like Lion King, you can thank humidity for that. The way that it's affected with air pressure. Animals also can have humidity because remember, they have a lot of fur. So if you see any animals outside, especially cats or any dog with a lot of hair, you'll know whether or not there's a lot of moisture in the air and the air pressure has decreased just by looking at the animal's fur and the way the fur is reacting to the outside. So if it's very humid, your hair is going to know it. In African American hair, when it's very humid, what does our hair do? It drops and it starts to curl or get a kinky feel. So that is what humidity does to our hair. Females and maybe some males who don't have like gel in their hair, but we really don't like humidity because it takes a toll on our hair. So humidity is Mother Nature's cruel practical joke on curly-haired people everywhere. So now let's take a look at low pressure. In low air pressure, the air molecules are moving far and they're moving fast. That's when you're in a low pressure. That's how the meteorologists know we're in a low pressure. The molecules are moving very far and they are fast apart. When we're in a high pressure, the high air pressure, the molecules are moving slowly and they're closer together. So that's how the meteorologist can tell you this area is in a high pressure because the molecules are moving slow and they're moving close together. So now, don't forget, as humidity increases, what does air pressure do? It decreases. When the altitude increases, what does the air pressure do? It decreases. And as the temperature increases, what does the air pressure do? The air pressure will decrease. So now how does air pressure affect things on Earth? How does it affect us? Because you know everything I got to relate to the real world. Could air crush a metal tank car? And this is the metal tank car. The inside of this tank car was washed out and cleaned with hot steam. Then all the outlet valves were shut. The tank car was sealed up. All the workers went home for the evening. In the morning, when they returned, this is what they found. Now, bomb didn't hit it because you have little particles all over the place. So we know a bomb didn't hit it. So they said that they cleaned it out with keyword hot water. All the valves, meaning any opening, it was closed off. It was sealed. And then they went to the house, they went home, went to bed, ate dinner, etc. But when they got back, somebody was mad because this is what they found. How in the world did this become that way? I'll let you think about it. And remember talking about air pressure. This tank, it was smashed, crushed, and collapsed by an unseen force. Couldn't see it. Remember, it wasn't a bomb that did it, because you can see that. Why did that force create this much damage? It's simply because of the air pressure was not what? It was not balanced. When you added that hot steam on the inside of it, it did not balance with the air on the outside of it. When you sealed the valves, the air could not get in, they could not intermingle together. So, since they could not, it simply did what it did with the collapsing can. It simply crushed within itself. The air has to balance. So that's what we're going to do with my experiment today. We're going to take a look at how air pressure increases and compresses inside of an enclosed space. Enclosed means something that's sealed in. So here's our lab, under pressure. Growing and shrinking marshmallows. Marshmallows are a delicious, fluffy staple of summer campouts and barbecues. As a matter of fact, if we had gone to camp this year, we would have had a campfire and you guys would have roasted marshmallows. Did you know that there isn't really much to a marshmallow? The best way to see what comprises the marshmallow is to put it in the marshmallow masher pressure test. You use the power of air to demonstrate what you're really eating when you roast a marshmallow around the campfire. So these are my materials. I needed small marshmallows, I need a pressurized pump, and a plastic soda bottle. So before you go to the experiment, and I'm going to say this again, and you guys, it's very important that you follow my directions. Before you go to the experiment, I need you to go to Kid Blog and answer all the questions for the before. How do you think the bottle of marshmallows feel when I squeeze it before I pump the air in? But this question, I asked you to start pumping air in, and then I remembered it, so I stopped and I squeezed it first. But you still would be able to tell what it felt like. Number two, after I pump air in the bottle of marshmallows, how do you think the bottle would feel? Number three, how do you think the bottle of marshmallows sound before I pump the air in it? And number four, how do you think it's going to sound after I pump the air in it? Because I'm going to shake it so you can hear it. And number five, what do you think would happen when I take the cap off the pressurized bottle? So go to Kid Block and answer the before questions. Answer the questions, fifth graders, before you open up the experiment video. Then after you open up the experiment video, I need you to pause this video. Pause this video. Go to the video that says experiment, what would happen when marshmallows are pressurized. Look at the experiment, and then I need you to come back to this video. Okay? You're going to go to Kid Blog, and you're going to answer those questions. Okay? So I'm going to say this again. Look at the experiment video. Go to Kid Blog. Answer those questions for the after the experiment. And then come back here so I can tell you how it works. So pause and go do the experiment. So how did that experiment work? I hope you like seeing it because I actually like doing it. I actually did it twice. The marshmallow is full of tiny bubbles of air. The air pressure inside these tiny bubbles is roughly the same as the air pressure pushing on the marshmallow from the outside. So the pressures are equalized and the marshmallows retain its regular shape. When pressure goes up, the volume of the gas goes down or it decreases. When the volume of the gas increases, the pressure goes down. Push the volume up and see the volume go down. So this is the bottle before I started to add the air in it. You see they're nice and fluffy. Nice and fluffy. This is the bottle after I added the air. And you see my line was here, and you see how far down the air pushed the marshmallows in the bottle. They're nice and fluffy, no wrinkles. Here you start to see how the marshmallows look wrinkly like a raisin. You also can see how they look like they're trying to melt together, but the only heat we'd had was heat pressure. So it's not like we had fire. We just had the constant rubbing together of the marshmallows, and it looks like that they were trying to melt. And then they start to look wrinkly. You know that the sounds sort of sound more like rocks hitting against the bottle because I took all the air out of the marshmallow when I put the air in the bottle. Volume in, volume out. Once I released the cap, I took the seal off the bottle. What did the marshmallows do? They started to go back up and again regain its original shape. So that's how air pressure works. You have to have that balance inside and out. The volume is going to increase when the gas decreases. Okay? So now what did this experiment teach you about air pressure? When more air molecules are added inside the bottle, the air pressure increases and compression. Remember, compress means to move downward. Compresses the marshmallows and the air that's inside of them. Remember, the only thing in a marshmallow is basically air and a whole bunch of sugar. When the cap is unscrewed and the air pressure returns to normal, the marshmallows return to their original size. So they went from here back to its original size. Now, can you think of other things that I could have used in a bottle as a variable to demonstrate the effects of air pressure? And I thought of four more things that I thought about over the years of me doing this experiment. I could have used foam. I could have put foam in there. Shaving cream would do the same thing. Packing peanuts, those peanuts inside of boxes when you get something and they put packing peanuts in it to keep it from breaking or whatever. Those are packing peanuts that would do the same thing. Now, actually, I did the packing peanuts either last year or the year before last as a variable. And then there's candy we get at Easter time called Peeps that also would have worked as a variable for the marshmallows. So, you guys, I hope you enjoyed the experiment and have a great Wednesday.